Hi everyone. Welcome to Not Your Normal Nerding. Today we're going to talk about water. I've done one about dams with with an understanding of water. So we're going to talk about the power of water and how the changes that have occurred with water, and once again, there's a simple side of it and there's a really complicated side to water that realistically no one ever talks about. So it's really a unique way of looking. It's once again my perspective upon all those little things that no one ever realizes, or maybe they do realize but no one ever talks about. So we're going to talk about the function of water, how the world distribution of water changes. There is global impact. There is a climate impact. We all know this global warming, all these things that occur, and the Earth's way of adjusting to it, and it creates an environment that humanity's scared of because it causes all these changes. We know the science behind the changes, and say all of the glaciers, the polar caps, let's just say they all melt because the rise in temperature is too great. Well, that's the Earth's way of coping with rising temperatures. That's normal. That's okay. What's not okay is because we have hundreds and hundreds of millions of people, humans, that live on the coastal regions of the world. My common sense says, why not just move more inland? But once again, nobody wants to give up their home, and we get it's the human psychology. I've lived here, I should stay here, so be it. And that's absolutely fine. But once again, the human fear is it's going to destroy their home. Well, it's not a big deal. You just build a home somewhere else. People move all the time. But once again, people want to stay close to the coastal regions. If all of the polar caps, all the ice melts, or so, yeah, the water level is going to rise. There's going to be less land overall that is not submerged. Human living capacities on land decreases. We got plenty of land. So the reality is that's a moot point. Who cares if global warming happens and all the polar caps melt or whatever it is? Well, we just need to move to regions that are better climate adjusted for us. So humanity can move more north and more south, so it's cooler. It's not too hot. The equators or so can be really, really hot, but as you move more north and south of the equator, it's cooler. Just don't move too far because it's frozen still. And even 10,000 years from now, even a worst epidemic of stupidity or so that causes global warming, all the carbon emissions that we give off, whatever it might be, the polar caps are still going to be pretty cold. There's always going to be a region or so on Earth that is just about the right temperature for humans to survive, and there's going to be enough room in that particular regions, both sides of the Earth as well too, north and south, so it'll be okay. But let's just talk about that in general is the water principle. Yeah, we don't like it. Is it a good thing or a bad thing? No, it's just a thing. It's a bad thing for humanity because it makes it more unhospitable for people to live on Earth, but that doesn't mean we can't live on Earth. Does it make our air more toxic? Yes. Does it make our water more toxic? Of course it does. Do we, as humans, have the technological fixes for that? Yes. So what's the problem? The problem is, as we make things more habitable for humanity, we make the world more toxic for humanity as well too. So only pockets of areas is livable, is habitable. Well, that's been happening for 1,000 years. You know, Chernobyl, we can't live around that area anymore. We just don't. Islands or so that get submerged because of earthquakes or volcanic activity, what do? We move somewhere else. Just think of the Three Gorges Dam that was created. Displaced like 1 million people, which moved 1 million people out of the way. Make dams all the time all over the world, and it causes certain areas to get more submerged. So what do? We relocate humanity to a place that's more habitable because we've made an area of the world uninhabitable for humans in an appropriate or feasible way. We've been doing it for 1,000 years. Why are people complaining about it now? I have no idea. It's just that humans find something to complain about, let them complain about it. But the reality of it is, this is just the normal. Us human beings will suffer from it in the long run, but Earth is not going to suffer from it. Species will die off, new species will evolve. That's just how the system replenishes itself. So water-wise, lots of salt water around the world. Water stays salty 97% of the water on Earth. 3% of the water that is something that humanity can use. I talked about how fresh water is made. Ocean water evaporates, goes up into the clouds or so, rains on land, and we got water, goes into rivers, goes into lakes, goes into portions that are lower than the surrounding area, creates waterbeds, tributaries, so forth. So we got plenty of fresh water. The world gets hotter, more of the ice melts, and in the end we dilute out the salt just a bit more, and we have more water available as we evaporate it. So there's a cycle that happens to maintain these levels of water on the world. So it's a good thing. Now, let's talk about how humanity uses water in a way that doesn't make a whole lot of sense. In the United States of America, a large portion of farming land is on the West Coast. Well, here's the thing about the West Coast. There's a part of the West Coast that does not get an appropriate amount of rainfall. Now, if you're going to start creating farms, and we're talking about tons of farms, the reality is for every acre of land, to raise crops, to raise food, whatever it might be, regardless if it's a cow or a piece of corn, that particular area of land is going to require more water. To the extent where when a world on the West Coast doesn't get a lot of water, where are you taking that water from? All these other places. They created lakes. Humanity creates dams up water locations to create water reservoirs. Well, a water reservoir is good for the normal flow most of the time. And if you think about the balance over dry periods and wet periods or so, it's a balancing act to provide just about the right amount of water for that region, but not necessarily in excess. So as we increase the utilization of farming, that increases the utilization of water in the area. So we start using it, and then once again, the distribution of the water itself means what? Those crops are being shipped elsewhere to the United States, to the rest of the world. So even though it doesn't look like we're shipping water, we're displacing water's utilization to create a crop or whatever it is. And we ship it off everywhere. So you're taking that piece of water and shipping it to another place of the world for them to consume. Well, if you keep the corn in the same area, you keep the whatever it is in the same area, you keep everything in the same area, would it be a bad thing? No, it would allow more soil to be fertile. It would keep technically the water within the area because you're keeping the crops within the area, the tomatoes within the area, whatever it is. So it changes the climate. The reality of it is, realistically, why not move the farmlands to areas that do have the appropriate amount of water, the water tables necessary for farming. The Midwestern. There are droughts. Back in the 1940s or so, Dust Bowl happened. I mean, there's always droughts that occur, but overall, if you look at climate change and all these and you factor it in, well, droughts are going to occur more on the coastal side of things, and as those places get hotter, water is going to be more prevalent. Precipitation is going to be more prevalent inland. So why not move farmlands inland? Midwestern is very, very good for it. It's like, why not? Of course, the problem turns out to be the year-round temperatures. They get really, really cold. So, if you look at fruit year-round or something tropical, it just doesn't happen in the area. If you look at marshlands like in Florida, yeah, you can grow tropical fruits there. The weather around is conducive. We just don't have a lot of solid soils, firm ground for that whole place to be farmland. If we made Florida an entire farmland, it would probably do better overall for farming than the West Coast would do, and not create so many water-related problems just for crops. So what do we do whenever the water runs low in an area because the rivers are not producing, the lakes are being depleted, the rivers are even getting worse, and there's no precipitation, the snow caps are not melting enough to create freshwater drainage. So humanity has decided, why not drill down to aquifers for water? The under the table water. So 300 feet down, 1,000 feet down, there's water down there. And we drill it, we pump it up, and we use it. It takes thousands and thousands of years for that water to replete itself, and we can decimate those water levels in less than 10 years. The sheer math doesn't add up. Is it worth it? The reality of it is it's not. So let's think of it from the not your normal nerding way of looking at it. Water is great at maintaining a certain temperature. So use this as an example. Say the sun was shining down on a block of air, oxygen, in a 1 meter by 1 meter by 1 meter cube glass box of air. You put a temperature probe right in the center of that. And you take the same box now and you just fill it with just plain, pure water. And you put a temperature probe in the center of that as well too. And you make sure they're the same temperature, 72 degrees. Let's just start there. And then you shine the sun on both boxes. What you come to find out is that box of air, the temperature rises a lot faster than that box of water, even though they're absorbing the same amount of sun. Well, so if you look at anything else, any other substance outside of air, let's just say gold, the reality of it is, if you look at 6 hours, 8 hours of the sun beating down on all three of them, you find that the temperature of the air, the temperature of the pure gold, and the temperature of water, surprisingly enough, the box of air and the box of gold, the temperature is still going to be higher than the box of water. Well, why is that? That's the cool thing about water. It is a polar molecule. No, its ability to absorb heat and not be energetic as it's absorbing energy is really that good. So it can sustain it can take in a lot of heat before it goes from 1 degree to the next degree to the next degree. Air, oxygen molecules, whatever, it doesn't require a lot of heat. It can warm up fairly quickly, even though in the same box there's less air and the sunlight will not hit every molecule. In the water, the sunlight's going to hit pretty much every molecule as it goes through. There's gaps. Air has gaps in it. Oxygen molecules at 72 degrees will have gaps in it. And if you look at a solid block of gold or so, there's no gaps. The sun's going to hit one area. It's not going to shine through it. So whatever it is that doesn't get reflected off the gold or so it's going to hit and it's going to absorb, and it's going to get warmer as well too. But not as fast as water. Why? Because that's water's design. Now let's apply it to aquifers. So first things first, as more water is being pumped out of these aquifers, first, that is part of the stability of the surrounding land. So less water means what? Land's going to sink because it's kind of like taking a piece of dirt out and out. Well, everything is now riding on more and more air. Well, air doesn't support anything, so the ground collapses. So as you drill more water out, the ground in that area will slowly sink. The other side of the coin is, okay, so you're in a drought-stricken world. You are going to take the one key thing that helps to sustain the temperature of that area as well too. So yes, you think about it, yeah, it's a 300 feet down, 1,000 feet down. It doesn't have the biggest impact in the world. Well, not right away. And that's the key thing is people look at it, hey, this year it's not going to impact. Well, that's because you haven't taken all the water out this year. You take more water out, and the water that the heat that didn't dissipate will slowly diffuse down. And as it diffuses down, and water does not, in a sense, keep it cooler, doesn't absorb that heat, what happens? The ground gets warmer and warmer. Even though it's a small fraction, but those small fractions add up because the water, it is a very, very cool substance where it can absorb quite a bit of heat compared to dirt or whatever it is before it rises, regardless of if it's a little bit of heat or whatever it is. Well, dirt is going to get warmer faster than water is. So water is good at, if you kind of mix it in, it helps to sustain the temperature of that ground. Now, you look at the ground, let's just say during the day, it's 80 degrees, and at night, it's 60 degrees. Well, but that's just the top. What happens to the temperature below that? Well, it's not just 60 degrees right away. It takes time for the heat to dissipate out. But if you have a lot of air and not a lot of water, first off, conduction does not occur in air very well. So it's an insulator as well too. So temperature, let's just say 6 inches down. Well, when the air temperature is 60 degrees and the ground temperature is 80 degrees, yeah, the top inch or two, it cools off really, really well. But let's just go 10 inches or 12 inches down. Is it still 80 degrees? Well, maybe that day it didn't get to 80 degrees. It only warmed up to 78 degrees. But that 78 degrees will stay a lot longer, and it doesn't necessarily dissipate completely. Maybe by 10 o'clock in the morning, that 78 degrees is now 74 degrees. And then today, the next day, it might be 80 degrees again. So it goes back up to 78.1 degrees. So once again, over time, the temperature of the ground rises and rises and rises. More heat occurs. So more heat causes what? More drought as well too. Heat causes water to evaporate. Heat causes more heat adds onto the heat. So it makes the world around hotter. It makes it harder for plants to grow. Why? Because the temperatures are so high that all the water that's placed down, it will temporarily cool off the top surface, but it doesn't cool off the ground completely. It still is not enough. It doesn't absorb enough heat. You know, the plants, they have to use water to do their photosynthesis, to create their fruits or their vegetables or whatever it is that humanity uses. So it's going to do everything it can. So all that water gets absorbed through the roots, and in the end, the ground still doesn't have an opportunity to cool down the way it needs to with the water. So those are factors that affect how water is utilized. So as we pump more water out of these aquifers and don't give them an opportunity to recover, what are we actually doing? We're actually helping the drought problem. We're supporting it. We're making it worse. Yes, moving a farming industry from one location to the next, well, we have all this data, we have all this knowledge. Why not put it into good use and maybe federally or country support, use the government systems to support the relocation to areas that would be better suited for farming. There's always a belt, there's always a location. So it's doable. The tropics are great for growing a bunch of fruits and vegetables year round because they have good temperatures. They don't get too cold. They don't have, seasons the way maybe Nebraska has seasons. So there's a possibility of all this relocation to places that would be better suited where we don't necessarily have to use water out of context or an over excess of water for human consumption. Humans use a lot of water, plants use a lot of water, cows, pigs, and chickens use even more water than plants to support what? Humans that waste water as well too, more than they should. Think of every keeping up with the Joneses front lawn that's green with grass and everybody's got to water their lawn. Why? Because it looks pretty. Is it a necessity? No, but does it look pretty or so? And that is the human psychology behind having a home and a yard to play in and all that? Yes, absolutely. So it's designed for the human success is because that makes us happy. Not a need, it's a want. But it does make us happy. If we stopped watering every lawn and used water more appropriately, would we have more water available for other resources like farming? Absolutely. If we stopped, pumping waters into fountains to make them look pretty, would we have more water available? Yeah, not by a whole lot. We do have this problem with evaporation in sunny areas. When the temperature around there is hotter than normal, it's going to cause more evaporation from our reservoirs. If it's more sunny, it's going to do the same thing. If evaporation occurs too fast, then what happens? The convection prevents clouds from forming, so we have more sun as well too. So more sun makes the world hotter, and hotter increases evaporation tendencies as well too. So our reservoirs get depleted with just evaporation, vapor pressures, and so forth alone. Well, that doesn't really help as we're depleting those resources, and then we're also depleting the resources that are underground, which also help to maintain the thermal stability of a particular area. People don't think about it, and people keep on utilizing them, and they don't realize as they're utilizing it, it's actually making water-stricken areas, water-depleted areas actually worse. There's that, the human side of, we gotta have plants to survive. They also create jobs as well too. Well, if that's the case, why don't we just move those farmlands, those farming capacities to areas that are not so water, what's the best word of putting it? Water challenged. That's what we're going to use. Those worlds are water challenged. Midwest, nowadays, this year, we've got plenty of rain that's happened in the Midwest area. It has plenty of farmlands available. Nobody farms here. Go figure. Tropics, there's plenty of land in the tropics, but it's too hot for people to live there. They want more comfortable environments, so be it. So we let the people who live in that region farm in that region. Well, like I said, it's like maybe the West Coast is not favorable for farming anymore. Why? Part of it is aquifers that we're depleting, which helps to increase the temperature of an area. Well, put that water back. Unfortunately, you can't. You have to wait for it to come back. How do we do that? Well, first off, conservation. Second of all, let's stop wasting water and move the resources to areas, or move the resource things that just take up those resources, those water resources, move them to areas that are not that resource challenged. I don't know how hard it is, but you know what? We spend a lot of money on stupid things. If we didn't spend money on stupid things or so, I think we could afford, and we have the financial capacities to do something that I would consider fairly simple. Thank you.